Okay, this video is going to show us how to solve a bunch of different kinds of things. Polynomial equations, radical equations, and rational exponents with some other fourth degrees at the bottom. So remember, when we're solving these, we're going to want to do this by making it equal to 0. So we're going to subtract the 50x from both sides. Let me change to something that's not yellow. So if we subtract the 50x squared, it's a minus 50x squared, and we set it equal to 0. So now we've noticed that both this term and that term have a 2x squared in common. So we factor out the 2x squared, leaving us with an x squared minus 25 in parentheses. And applying the zero product principle, either 2x squared has to equal 0, or x squared minus 25 has to equal 0. One of these two values must be 0 in order for their product to be 0. So if 2 times some number squared is 0, that means x has to be 0, because that's the only way you can square something and times it by 2 and still get 0. Or we'll add 25 to both sides, so x squared equals 25. And when we square root 25, we have to remember that not only do you get a positive 5 value, but you also get a negative 5 value. So when we're solving by square rooting, you always get a positive and a negative. When you're just square rooting, you're probably only going to take the positive. So here we have 3 answers, negative 5, positive 5, and 0 turns out to be a double root, so that we have 4 total answers for our fourth degree polynomial.
Wait, why 4?
Okay, so on this one we notice there's 4 terms, an x cubed, an x squared, an x, and a number. So the best way to solve this one is to factor by grouping. So we're going to solve this by grouping. So factor by grouping. So when we group this, you want to make sure that everything is on the same side of the equal sign. And we group the first 2 terms together, and we group the second 2 terms together. And we look at what they have in common. So we notice that both of these terms have an x squared in common. So that leaves us with a 2x and a minus. Well, here everything is gone. And when everything factors out, you must represent it with a 1. So that when you multiply it back in, x squared times 1 gives you that x squared value. Okay, so it's not gone. You have to make sure you have a 1 as the placeholder. And negative 18x and positive 9 both have a negative 9 in common, leaving us with a 2x and once again a minus 1. So that negative 9 times negative 1 gives you a positive 9, exactly what you started with. So now we have another common factor. Both of these terms have a 2x minus 1 in common. So we factor that out, and that leaves us with an x squared minus 9 left over. So once again, we're going to apply the zero product principle. Either 2x minus 1 has to be the 0 term, or x squared minus 9 has to be the 0 term. So solving both of these, we'll add 1 to both sides and divide by 2. So one of the solutions is 1/2, positive 1/2. Okay, and the other one, x squared minus 9, so we'll add 9 to both sides. X squared equals 9. And when we solve by square rooting, we get a positive 3 and a negative 3. So here we have 3 solutions. It's a cubic equation, so you should expect to have 3 solutions. This one matches up just fine. Okay, solve by grouping. It's a good thing to do when you have a cubic and then a squared and an x and a number. So here's 2 more examples of solving by grouping. We'll run through them really fast. So we're going to move everything over to one side of the equal sign. X cubed plus 2x squared minus 9x minus 18 now equals 0. Okay, once again we'll group the first 2 terms and we'll group the second 2 terms. So these have an x squared in common, x plus 2 left over. These have a minus 9 in common, x plus 2 left over. So once again we factor out the x plus 2 because both terms have that in common, and that leaves us with an x squared minus 9 Okay, and cutting all these things short, we're going to have a -2 solution from the first set of factors, and this is going to give you once again a +3 and a -3, just like it did a minute before. Okay, one more factor by grouping, x plus 3, and then we have a -2 in common over here, leaving us with another x plus 3. So x plus 3 factor, x squared minus 2 factor. So here, of course, we get our -3 solution, because -3 plus 3 is 0. But over here, let's get x squared minus 2. So x squared equals 2. And when we square root this, because 2 does not have a pretty root, of course, we just leave it as a radical. So the square root of 2 is one answer, and the negative square root of 2 is the third answer. Okay, so just be aware that not all answers will be square rootable in this type of a problem, which is perfectly okay. We could even get imaginary solutions. If we happen to have an x squared plus 2, then we would get an imaginary square root there. So there's all kinds of answers are possible, not just real ones, but irrational and rational. Okay, so there's some solving polynomials, traditionally by grouping or by factoring. So let's move over and solve some radical equations. Now with the radical equations, you need to get the radical by itself. So let's subtract x from both sides. That gives me the square root of 2x minus 3 equals -3 minus x. And the inverse operation for a square, hopefully we know, is a square root, and the inverse operation for a square root is a square. So we solve these radical equations by squaring both sides. Over here, the square root and the square cancel out, and we're just left with the 2x minus 3. Over here, remember what it means to square. That means to multiply it by itself. So -3 minus x times -3 minus x. -3 and -3 is +9, plus 6x plus what? So plus 6x total. There's a minus times a minus is -3, minus and a minus, and then another plus x squared when you do the -x times a -x. So now we're going to bring this over and make a quadratic, all for one and one for all. So 0 equals x squared plus 4x. So 6x minus 2x is 4x. 9 plus 3 is 12. So x squared plus 4x plus 12. Are there numbers that multiply to give you 12 and add to give 4? Doesn't sound familiar. So we would have to solve this one using the quadratic formula, which is on another video. So if you want to know how to do that, just look over there. We're going to continue, though, on to this next problem. So this next one we're going to solve the same way. We're going to move the 5 over to the other side of the equation so that we have our square radical alone. Okay, we solve our radical by squaring both sides. Everything gets squared, not just each piece individually. So we have an x minus 3 on the left, and when we square this out, x squared minus 10x plus 25. So remember, it means to multiply it by itself, not distribute. So x times x is x squared. We have 2 minus 5x's and -5 times -5. So now we'll bring everything over to one side, make a quadratic. Plus 3 plus 3. 0 equals x squared minus 11x plus 28. So this one is in fact factorable. The factors of 28 that add to give 11 are -7 and -4. Okay, and we can check it. -7 times -4 is positive 28. -7x and -4x is -11. So our potential answers, and I say potential because we have to check them, are 7 and 4. So we check them by plugging back in. So if I had the square root of 7 minus 3 plus 5, does that end up giving me 7? That's the question. 7 minus 3 is 4. The square root of 4 is 2. 2 plus 5 is 7. Sure enough, 7 is going to be a solution. Okay, so now let's check on 4. 4 minus 3, that's 1. The square root of 1 is 1. 1 plus 5, does that equal 4? No, it does not. So 4, even though it's an answer, is not actually a solution. So in this case, your only solution is the 7. Okay, so on most radical equations, you should be going back in and checking to see if your answer is actually a solution. Okay, one last example. We're going to add x to both sides to get rid of it so that we can square. And we end up with 10 minus 3x equals x squared. We make everything into a quadratic, plus 3x minus 10. So we have factors of positive 5 and negative 2, which have answers of negative 5 and positive 2. So these are our answers, but let's check to see if they're actually solutions.
What if they're both solutions?
Then they're both fantastic if they're both solutions. It can be possible that both numbers will be solutions. It won't always be one or the other. So 10 minus 3 times negative 5 minus negative 5, does that equal 0 is the question. So this is a positive 15. The square root of 25 plus 5, does that equal 0? Not last time I checked. That gives you 10. So let's see. What about 10 minus 6 minus 2? So 10 minus 6 is 4. The square root of 4 minus 2 does in fact equal 0. So it looks like 2 is going to be your only solution. So even though we had two answers, when you plug them back into C, you only actually get one solution. So make sure you check that. So our next little topic was some rational exponents. Okay, so rational exponents means you have a fraction as the power. So we solve this like we solve anything else. We need to get the radical thing by itself. So we add the 24. 3x to the 3/4 power equals 24. We're going to divide everything by 3 because we want to get x by itself like we always have. So x to the 3/4 needs to equal 8. So here's where we start solving it. You always do the inverse of what we have. So if we're squaring, you would square root it, which is raising it to the opposite power or the inverse power, so the 1/2. So we're going to multiply or raise this to the 4/3 power to get rid of our 3/4. So we raise both sides to the reciprocal power. So because it was a 3/4, we're raising it to the 4/3. 3/4 times 4/3 is 12/12, which is just 1, which is exactly what we want, x to the first power. On this side, on the other hand, we have to interpret this 8 to the 4/3 power. Okay, so whenever we have a rational exponent, the bottom number is your root. So in this case, we're going to be taking the third root. The top number is your power. Okay, so there are two ways to write this. We could write this as 8 to the 1/3 power to the 4th, or we could write it as 8 to the 4th and then raise it to the 1/3 power. Okay, either way, whichever one you're more familiar with, do it that way. Me, I'm more familiar with this because the 1/3 power is actually the third root of 8, and I'm okay doing the third root of 8. I have memorized that one before. The third root of 8 is 2 because 2 times 2 times 2 gives you 8. So 2 to the 4th is just going to be 16. Okay, now I'm not sure what 8 to the 4th power is, but I know a calculator can handle it. But if you're not allowed a calculator, then you need to do what your memory tells you what you know how to do. So of course your calculator can handle this if you plug it in there, but if you're not allowed a calculator, you need to know another way. Okay, so similarly here, we will start off right off the bat getting rid of this so we can get rid of our parentheses. So we're going to raise this to the 3/2 power because that's the reciprocal of 2/3. So over here, we can either write this as 25 to the 1/2 cubed, or we can first cube 25 and then find its square root. Okay, I'm more familiar with this way. 25 to the 1/2 power, well, that's just the square root of 25. I know what that is. The square root of 25 is just 5. 5 cubed is 125. So over here, when you get rid of the parentheses, we get x minus 7 equals 125, and adding 7 to both sides gives you an answer of 132. Okay, so do whatever your brain is more familiar with. My brain is more familiar with taking the square roots rather than cubing it and then square rooting. That's a very large number. Okay, and then the last one, we're going to solve this by factoring. We're going to solve this 4th degree like we would solve any other regular old quadratic. Numbers that multiply to give you +4 and add to give -5 are -4 and -1. Now, unlike your normal standard factors, these things factor with an x squared in them, because we want x squared times x squared to give us an x to the 4th power. Okay, so if you set both of these equal to 0, we get plus and minus 2, and we get plus and minus 1 as your 4 answers to this one. Okay, so there's a lot. I know it's a lot of stuff and it's kind of long, but it is just algebra. You have some radicals, some rationals, and some polynomials.